Hi, and welcome to Applied AI Series Part 4. This is the continuation of the previous part, Machine Learning with Regression Analysis. And this is Part 2 of that. This series is brought to you by Skills Zakhira, and I am Dr. Sadaf Zishan. Now, in Part 1, we discussed what is a regression model and what are the types of regression model. We also looked at how linear regression model works. We taught a machine to guess numbers like prices, marks, etc. But how do we know if it's doing a good job? For that, we discussed to check the model if it's working correctly or guessing correctly and making correct predictions. We have certain check indicators, you can say. So first of all, let's discuss what is an error. So when the machine says the value is 50, but the real value is 60, so there is a difference. This difference between the actual value and the predicted value by the predicted line that we have is called error. So in this case, you see the difference between the real answer and machine answer is 10. Now we want the machine guesses to be very close to the real value. So every time we run a model, a regression model, we calculate various types of accuracy tests and checks and errors. So the first test that we do is we check the mean absolute error. Now this, what it does is we take all the points and we take an average of all the errors. We add up all the errors and we divide it by the number of guesses. You can see the formula over here. We have the predicted values, the actual values, and then we take an average and divide it, average by dividing it by the number of guesses. The smaller the mean absolute error, the better the model is going to be. Now think of it as how wrong an average is in a machine. So this is one criteria to check if the model is a good model. The second method is mean squared error. Now, please note, all mistakes or errors are not equal. A smaller mistake can be ignored, but a bigger mistake can make a big difference in the performance of a model. So bigger the mistake, the more it hurts. So by squaring of the errors, we make sure that big mistakes get extra penalty or they are identified more. So what we do in mean squared error is that we square the errors first, then find the average. This way, in the bigger mistakes, as you can see, the bigger boxes are going to pay a more price as compared to the smaller errors. So the formula over here is similar, just the difference of a square. Third is root mean squared error. Now, this error is easy to read. We take the square root of MSE, mean square error, as we already did previously. So this is exactly the same. We've just taken the root mean square. What it does is it shows how far off the guesses are on an average and brings it back to the same unit also. So we have the different values and different errors. We take the square divided by the number of guesses and take the under root of it. Before we move on to the next type of accuracy check, let's discuss what variance is. Variance is how spread out is the data. It tells us calculated by the formula as shown on the diagram. So an example to understand variance is how if I'm testing a class and I've given a quiz to a class and all the class is scoring, let's say, 8 or 9 out of 10, then this data is close by. But if there is more variance, somebody's scoring a 2, some is scoring a 5, or the lots of 8s, or lots of 3s. So the data is spread out. Spread out. The marks has a lot of variance. R square is the smartness score. R square tells us how much variance is there in the model. So you can see on the diagram on the right side, the data is less spread out, whereas on the left side, the data is widely spread out. So R2 tells us the spread variance of the model. So R square, if it's equal to 1, that's a perfect guess. And if R square is equal to 0, it is not very good at average guessing. This will also affect the accuracy of our model. Next, we will discuss what is overfitting and underfitting. Now, sometimes when the model tries too hard or too little, it can result in two different scenarios. Now, for example, I have 10 sets of data, 10 questions, and I've rote learned every question same to same. And every time I get a question without understanding, I give you the answer, just like rote learning. This is an example of overfitting. So I memorize the training data that when I get a variety or if I get a different question, I might not behave the same way. So that's called overfitting. So I'm going to give you a great data every time. Underfitting is when we don't learn enough. When we overlearn it, that's overfitting. When we don't learn at all or enough, we don't have enough data to train ourselves properly, that is underfitting. So when the data is not trained enough to make the right prediction. So you can see if I have a set of data, just make a straight line. I have not understood the pattern of the data and I do not have, or I do not have enough correct data to make the correct pattern. So this will be an example of an underfit. Then there's something called an outlier. For example, outliers is something when we have an odd one out. For example, everyone is following a certain pattern and one data is totally off, maybe because we took the wrong reading, or maybe if we consider these points in our model, it is totally going to disrupt or affect the accuracy of the model and confuse the model, in fact. So outlier is a data point that is way different from all the others. It's like a very tall or a very short person in a class that stands out. Example, if most students score between 60 and 90 in a test, but one scores a 2 or a 10, too low or too high, that person is an outlier. So why outliers matter in regression? They can pull the line away from the right direction. So if I include outliers in my data, it is going to spoil the pattern. It is going to disrupt the line in a different direction. It makes the error bigger and it can also confuse the model. So it's a better idea to remove the outliers from your data set before making a model. How do we know if a model is a good model? So we learned today the checklist to check if a model is a good model is we need to have a low root mean square error, high R square, no overfitting or underfitting, good results on new test data. And yes, if all these checkpoints are there, then we can trust our model to do a good job. So make sure to remove outliers from the data also. Like and subscribe for more such videos and stay tuned. And remember,